Okay, geometry, here we go into the fourth section here of the section that just will not die, 3.8. This is what we're calling part D. And in here we're going to get into writing equations of lines given different types of information here. But before we get into that, just kind of a quick little aside. We're going to start off talking about two special kinds of lines here that kind of defy a lot of the other things that we've talked about so far in this section, and that would be horizontal and vertical lines. We've kind of skirted around some of these issues here in some of the previous sections. Now we're going to go ahead and just put it all together right here. So I find that this little table here is a good thing to have in your notes just so you can study this one quickly. When we talk about types of lines, the two special ones we're dealing with here are horizontal and vertical lines. And horizontal lines, you'll recall, just go straight from left to right without having any increase, rising or falling as they move from left to right. So way back in our first section of notes in 3.8a, we talked about the slope of a horizontal line. If you're moving from point A to point B, you have no rise at all. You're not going up or down, but you do have a run going from A to B. So let's just make up a number and say that that run is 5. But what really happens that's important is that your, oh boy, I can't spell it all, is that your rise is equal to 0. You're not going up or down at all. So when we go to find the slope of a horizontal line, it would be your rise over your run, which would be 0 over some other number. I just made up the 5 right here. And anytime you take 0 divided by a number, you are always going to get 0 then for your result. So every horizontal line has a slope of 0. And my silly little mnemonic is to remember that 0, of course, looks like the letter O, and the word horizontal has 2 O's in it, unlike the word vertical, which has none. So that's something we talked about in 3.8a. Let's also then revisit what we did with the slope of a vertical line. And a vertical line, one that goes straight up and down, if we wanted to move here from a point that we will call A to another point here that we will call B, in this case, we have a rise going up from A to B. So again, let me just make up a number and say that that rise right there is 8. Let's go with that. Sure, just some number right there. But what we don't have in going from A to B is any kind of run at all. We have a run of 0 because we're not moving horizontally. So when we go to compute the slope of a vertical line, our rise is going to be some number like 8, but our run is going to be 0. And unlike what we had right here, guys, where 0 divided by a number is going to get you 0, in this case, this is one of these things that people have a hard time remembering. Any number divided by 0 is going to get you an undefined slope. Okay, and remember we also can say no slope. That means the same thing there when we're talking about vertical lines. And the way I remember that is that vertical begins with the letter V and undefined begins with the letter U, and those letters are right next to each other in the alphabet and they kind of look alike. So that's something we already talked about in 3.8a, but now what I wanted to knock out real quick was the equations of horizontal and vertical lines. Okay, now you're going to get a little bit of practice at this later on in this section, so I'll explain this a little bit better. But when we're dealing with a horizontal line, your equation here is just going to be the line y equals, and then it's going to be some constant that comes after that. Now the constant I'm going to choose to put right here is b, and I'm choosing that for a reason. We've seen the variable b used in this chapter at all, and b then, maybe we'll write that right underneath right here, that b is your y-intercept of your particular line. So that's why I chose the letter B as opposed to C or A or anything like that. So what's unique about the equation of a horizontal line is it is simply y equals a constant, like y equals 7 or y equals -2, but there is no x to be found in that equation. Again, later on, we'll see that illustrated. And so, as you might be able to guess then, the equation of a vertical line has a similar trick, but with one fundamental difference. Whereas a horizontal line is y equals a constant, this vertical line is going to be x equals a constant. And instead of choosing b, this time I'm going to put the letter a. And right underneath that, we'll make the little note right here that a is the x-intercept of your line. So let's see those two concepts in action. But before we do, I just want to make sure that everybody has this table here written down in their notes, because this is pretty good information to make sure that we have committed to memory here pretty soon. That in a horizontal line, your slope is 0, and your equation is y equals some number, your y-intercept b. And in a vertical line, the slope is undefined, or we would say it has no slope. And the equation of a vertical line is going to be x equals some constant, and that constant a is your x-intercept. So really quickly, let's just use this information right here. Let's graph each of these two lines. So what you'll notice here is the first line we're going to graph, y equals 2, is unique compared to everything else we've done in this chapter because it only has a y and it does not have an x. So as soon as you notice that your equation only has one variable and not two, you might want to jump back to this table right here, and in this case realize, oh, we're dealing with this equation right here. Y is equal a constant. So if I kind of read that backwards, that means that we are dealing with a horizontal line here. And this number here, b, is the y-intercept of that line. So, looking at this again, I can tell that the line y equals 2 is horizontal because it does not contain an x, and that b, your y-intercept, is this number right here, which is 2. Now, you guys have dealt with y-intercepts before this chapter. We would simply go from the origin 2 units up and make a dot right there. And now, because we know the line is horizontal with a slope of 0, there's only one horizontal line that can be drawn through that point, and it would look something like this. So that's it for the first part there, guys. That's the graph of this particular line, y equals 2. Now, just kind of for fun, let me point out a couple of points that are on this line. This one is the point 0, 2. And again, just finding a few random ones, this looks like it's the point 5, 2. And maybe, I don't know, this point right over here, I believe is the point -7. 2. And what do we notice about all three of those lines, all three of those points? They all have the exact same y-coordinate of 2. And that's really what we're saying with the equation y equals 2. They want us to graph all points that have a y-coordinate of +2, and that's what that line represents. So doing the second example here on the same graph here, everybody, let's take a look at the line x equals -6. Now again, the first thing you should probably notice right here is that what's unique about this line is that we have an x here, but no y in that equation. So in this case, let me grab a different color highlighter right here, maybe make that a little, there you go. In this case, we're looking at this, guys. X is equal to a. X is equal to a constant, but there is no y value, and that tells us now we are dealing with a vertical line, where this number here, a, is your x-intercept. So back to where we were just a second ago, x equals -6 is going to be a vertical line. Let's write that down. And our x-intercept, which is what we call a, is going to be -6 here. So we don't spend much time dealing with x-intercepts. They work the same way as y-intercepts, except instead of crossing the y-axis, we now cross the x-axis at -6. So from the origin, I'm going to go 6 units to the left, which I believe is going to get me right here. And now I'm going to draw the one and only vertical line that passes through that point. And so the graph of x equals -6 is going to look like this. And if I were to just name here a couple of points on that line, that was -6, 0. I don't know, up here maybe, looks like it's -6, 5. Maybe right here would be something like -6, and then I believe 1, 2, -3. What do we notice about all three of those coordinates? An x-coordinate of -6, which is exactly what we were trying to say here. So that's how you graph horizontal and vertical lines, but of course the first step to that is actually recognizing that they're horizontal and vertical. Okay, so that was just kind of a little a skill we wanted to emphasize at the beginning of this section. Now we're going to get into the real meat and potatoes of section 3.8d, where we are writing the equations of lines. Now I want you to notice the directions here, guys. In each one of these problems, we want our final answer in slope-intercept form. Okay, slope-intercept is really the one we are the most familiar with right there. But what we're going to find is that slope-intercept form isn't always the easiest place to start with some of these equations. But hopefully by now we've done enough talking so far this section that we're going to know how to get there. So let's take a look at one example at a time, and most of these just kind of add a layer of complexity as we go through each one. So our first example A, let's take a look at the information that has been given. They want the equation of a line here with a slope of -3 and a y-intercept of -1. Now, if we think about what we need to get an equation in slope-intercept form, pay attention to the name. Say the words out loud. If I want an equation in slope-intercept form, I need to know the slope and the y-intercept of that line. And sure enough, in example A, what were we given? The slope and the y-intercept. Guys, this one's a gift. You're not going to see many problems this easy before. Again, everything that we needed was told directly to us. M, our slope, is -3. B, our y-intercept, is -1. So when we go to slope-intercept form, which is y equals mx plus b, we need numbers to put in here for m and for b. And guys, we've got them. In this problem, it's going to be y equals, our slope is -3. We follow that directly with an x, and then plus our y-intercept of -1. And rather than writing plus -1, we're just going to write -1, and that's it. Okay, that's a really simple problem right there, guys, because everything you needed was spoon-fed directly to you. Okay, you were given the slope, you were given the y-intercept, and there you go. Now, it gets harder than that starting right now. So let's take a look at example B, and let's see how that one's different. Now, just like in A, we were given the slope. Okay, but instead of being given the y-intercept, now we've been given a random point that this line passes through. So again, guys, what we know right here is the slope and a point. Let me say that again, but backwards. We know a point and we know the slope. So, what form of an equation have we been dealing with lately that we said was pretty good to use when you know a point and the slope? We are going to begin here in point-slope form. So one thing that I'm not sure that you guys quite got, I'm not sure if it came across as well as it should have when we talked about point-slope form, is when you would choose to use it. You would want to use point-slope form when you were given, let's say it again, everybody, what two pieces of information? When you were given a point and the slope, we want to go to point-slope form. So the generic version of point-slope form is y minus y1 equals m, and then in parentheses, x minus x1. And we are now going to fill in values for y1, m, and x1, all of which was given to us here and here. So this is going to be y minus our y coordinate here, which is 1, equals m, our slope, which is 2, and then in parentheses, x minus your x coordinate of the point you know on your line, -3. And minus -3 just becomes plus 3. And that's our equation, everybody, in point-slope form. And if the directions just said write an equation of each line, we'd be done. But the directions specifically say, and most of your homework questions will say this too, write the answer in slope-intercept. So we started in point-slope because that was the information we had. We knew a point, we knew the slope. So that's where we began, but we're not done now. Now we need to go just a little bit further and put this thing into slope-intercept form by, maybe make yourself a little note right here, guys. What we're going to do is we are going to solve this equation for y. When you get y by itself, that is when you're in slope-intercept form. So we're going to solve this for y by first distributing that 2. And we'll have y minus 1 equals 2x plus, and 2 times 3 is 6. And the last thing we need to do now is add a 1 on both sides of this equation. That cancels. And we'll get y equals 2x plus 7. And there's our equation in slope-intercept form, just like we were supposed to do. So that is our answer for example B. And if you wanted to check this real quick, guys, which I always think is a great idea, let's take this point right here, -3, 1, and substitute it into this equation for x and for y. We should end up with a true statement when we do. So in for y, I'm going to put our y coordinate here of 1. That equals 2 times an x coordinate of -3, and then a +7 at the end of all that. So 1 equals 2 times -3 is -6, and -6 plus 7 is 1. We ended up with a true statement, so I feel pretty good about this answer right here, and that is in fact the correct answer here for B. Also notice the slope of that line there is 2, which is the other thing we said that this line had to do. So that's how you handle an example, guys, where you were given the slope and a point. The first thing you do is go to point-slope form, and then from there, convert point-slope into, let me make a little note right over here, we were in slope-intercept form by the end of that, and it just takes a few steps, really, to get from point-slope into slope-intercept. Okay. If we were doing these notes live in class, guys, the question I would ask you right now is, does example C look any different from what we just did? And I'll have you think about that for a minute, and hopefully you guys would tell me that in comparing C to B, it's the same type of problem. In both of these problems, you've been given the slope and you've been given a point. So if you are given the slope and a point, or let me say it backwards, a point and the slope, then the best place to go initially here is point-slope form. Now again, we're not going to stop when we get there. This is really just a means to an end. This is a way to get to slope-intercept form. So point-slope form is going to be y minus your y coordinate of -7. Minus -7 becomes plus. Equals your slope now, which is -1/2, and then in parentheses, x minus your x coordinate, which is 8. So there's the equation in point-slope form, but again, the directions asked for it in slope-intercept. So it's just 2 quick steps to get there. We distribute our slope first. So we're going to have y plus 7 is equal to, and this will be a -1/2 x. And you guys are welcome to use your calculator here, but -1/2 times -8, hopefully you can do that in your head. A negative times a negative is a plus, and half times 8, well, that means 1/2 of 8. That's going to end up being 4. And lastly, to get y by itself, all we have to do is subtract a 7 on both sides. Those 7s cancel, and this should be our answer, guys. Y equals -1/2 x, and a +4 minus 7 is going to get us a -3. So I believe that's the right answer, but let's check it by taking this ordered pair and plugging it back in here and making sure it works. Our y value here is going to be -7. That's going to equal a -1/2 times an x value of 8 and -3. So -7 equals -1/2 times 8 is going to be a -4, and -4 minus 3 is -7. Check yet again. Got another true statement right there, so I feel really, really good about this answer. Also checking to make sure the slope of this line is supposed to be -1/2, and it looks like it is. So, feel really good about that. So those two examples there, guys, B and C, are both the same type of problem where you've been given the slope and a point, and you had to go to point-slope form. Now, if we take a look at example D, this is where the plot starts to thicken a little bit and things get a little bit more difficult. Now, this is a great opportunity to talk about what a lot of us do when we see something new, is we kind of tend to throw our hands up in the air and said, I don't know how to do this problem, and then just wait for somebody to bail you out. And what we really ought to be asking ourselves is maybe a little bit better of a question here. What is it about this problem that scares me, even if I understood how to do this problem? What did I know here in C that I didn't know here in D? Well, hopefully this is obvious. In B and C, the slope was given to you, and here it's not. So then the logical next question to ask yourself is there enough information here for me to find the slope so that this problem feels more like example C here, and then I would know what to do if I got there? Well, hopefully you guys know where this is going. There is a way to find slope, and this is the formula that we've been using for this whole section. M is equal to y2 minus y1 all over x2 minus x1. So we've got everything we need right here to find our slope. y2 is going to be 7 minus y1, which is negative 8. So minus negative 8 becomes plus 8. Down on the bottom, x sub 2 is going to be 4 minus this negative 1 right here. Minus negative 1 becomes plus 1. That gives us a 15 on top and a 5 on bottom. Oh, and that works out nicely. The slope is a whole number here of 3. Now at this point, everybody, we know our slope and we know 2 points that our line passes through. So that's actually a lot like where we were at the start of this problem. The only thing that's maybe a little bit confusing here, we actually have more information than we need here. We really only need the slope and 1 point, but instead we have the slope and 2 points. So I would tell you guys, make a decision right now. Which of these 2 points do you want to focus on? I would circle that one, and just temporarily I'd cross out the other so you don't make a mistake here. So I'm going to go with the 4, 7, and I'm going to cross out that negative 1, 8. And what we're going to do is focus on the point and the slope that we know, and we are going to go where? Point slope form. Say the words out loud, everybody. What do I know? A point and the slope, so I'm going to point slope form. This is going to be y minus your y coordinate, which is 7, equals your slope, which is 3, and then times in parentheses x minus your x coordinate, which is 4. So there's the equation in point slope, but again, the directions say put it in slope intercept, so we solve for y. We distribute that 3 here and get y minus 7 is equal to 3x minus 12, and from there, plus 7, and I think we got it here, guys. Y is equal to, that's going to be a 3x and a minus 5. So I believe that's our answer. But now what I want to do, guys, is I want to go back to this point that I ignored here a while ago. Let me box this thing up now, and I'm going to use that point as my test here, and let's see if it works. So I'm going to switch to green for my calligraphy pen here, and here we go. My y value at this point is negative 8. That equals 3 times an x value of negative 1 minus 5. So negative 8 is equal to 3 times negative 1 is negative 3. Negative 3 minus 5 is negative 8. Check. There's our answer, guys. Y is equal to 3x minus 5. Now, if we were in class right now, I'd have you take a look at point E, and I'd have you guys try this one on your own. So if you're watching this video, I'd say, hey, go ahead and pause it right now, try example E with a friend, and see how you do, and then hit play, and we'll come back and finish it up. Okay. Hopefully you did that there. Same thing going on in E that was going on in example D. We don't know the slope, and we need to, so the first thing we're going to do here, guys, is our formula for slope. y2 minus y1 over x2 minus x1. So y2, our second y coordinate, is 11, minus negative 4, that's going to become plus 4. Down on the bottom, x2, which is negative 12, and then minus your x1 value, which is 8. Okay, let's simplify, guys. 11 plus 4 is 15. Negative 12 minus 8 is negative 20. Simplifying this, we can divide out a 5 from both sides and get a 3 on the top and a 4 on the bottom. And you'll notice I had a negative on the bottom. I always recommend that you guys move the negative up to the top. I just think it's easier to deal with. And right there, guys, we just found our slope. So we know our slope and we know 2 points. So we are going to go to point slope form. Now, just like last time, you have 2 points right now. You only need one. So pick one of them. Either one will work. I'm going to start with this one right here, and I'm going to go to point-slope form. Y minus your y coordinate of -4, so that means +4, equals your slope of -3/4 times, in parentheses, x minus your x value, your x coordinate, which is 8. So there's an equation in point slope, but we need it in slope intercept, so let's solve for y. We're going to distribute the -3/4 and get y plus 4 equals a -3/4 x. Negative times negative is positive. And again, feel free to use your calculator here, guys, but 3/4 times 8 is going to get you 6. Then we're going to subtract 4 from both sides, and this should be our answer now, everybody. Y is equal to -3/4 x, and that's a +2 at the end of all that. So I think that's my answer, but I'm going to check it now, just like I have been doing, by using this point right in here. Let's try it. Our y value is 11. That equals, hopefully, -3/4 times an x value here of -12 plus 2. Use your calculator here on the right side, guys, but -3/4 times -12 is 9. Then there's a +2 at the end of all that, so 11 equals 11. Yep, that's exactly what we wanted to see, so that's our answer here for E. All right, guys, that's a lot of work here. I have what looks like, well, it is, 2 more problems for you, but these ones work a little bit different than the last 2. Let me shut up here, and you'll actually see why when we get to it. At first glance, F looks exactly like the last 2 problems we just did. We've been given 2 points, and we're going to find the slope that goes between them. So let's do it. Y2, your second y coordinate, is -3, minus y1, which is also -3. So that becomes +3, all over x2, which is -1, minus x1, which is 5. And an interesting thing happens now, guys. Your numerator, -3 plus 3, becomes 0, and your denominator of -7, all right, gives you that. And when we divide 0 by any non-zero number, we always get 0. So what that tells us right now, guys, is that this line is horizontal. And if you can't remember where that came from, let's go all the way back to that table that we did on the very first slide of these notes here. Any line with a slope of 0 is horizontal. Now, it would be cool if you guys had this memorized here, that the equation is just going to be y equals b, but the nice thing about this is you don't even have to know that. Let me show you what I mean. We would go to point-slope form right now, and I'm going to use this point right here. Watch what happens when I just try to go to point-slope form. Y minus your y coordinate of -3, well, that becomes y plus 3, equals 0, that's your slope, times x minus 5. So that would be the equation in point-slope form. But in slope-intercept, we would solve this for y first by distributing. Well, this is going to be interesting. Y plus 3 equals 0 times anything is always going to equal 0. The x is going to drop out right here because it got multiplied by 0. And now to solve for y, all we do is subtract 3 on both sides. And that gives us our final answer of y equals -3. Now, back to what we did on the first slide. We said that if your slope is 0, your line is horizontal, and your equation will be y equals b, a constant, which is your y-intercept. And that is exactly what happened here, guys. All the x's dropped out. We ended up with y equals -3, and this number is your y-intercept. Now, what I think is really, really interesting, I would not do this if I were you guys here, is that you could actually, oh, you're going to get mad at me for saying this, you could erase every bit of work that we did right here, and you could actually have gotten this answer just by looking at the problem without doing a speck of work. what do you notice when you look at these two original points here? They have the exact same y coordinate. So in both of these 2 points, your y value is -3. And that happened here as well. And every other point that's on that line is going to have the same y coordinate. So since they both have a y coordinate of -3, our answer is y equals -3. So I don't know, I don't really recommend that you guys would do a problem like that if it showed up on a quiz or a test. You certainly can get to this answer doing it the regular way, but I would give you full credit. You might want to check with your own teacher about that, but if you were to just say, hey, I see this and I see this, so the answer is y equals -3, I would give my students full credit for that. And if that makes some sense to you, okay, hang on a second, let me get rid of it. Okay, if that made some sense to you, this problem might make some sense as well. Now you'll notice this isn't exactly the same as the problem we just did, but what do you notice? These 2 points have the exact same x coordinate. This one has an x value of -5, and this one has an x value of -5. So if you just want to piece 2 and 2 together right here, you might realize that this equation for this particular line, you guys, is x equals, well, -5. And going to be honest with you, that's the answer. Now let me walk you through what this problem would look like if you did it the normal way. You'd find your slope first. So we would start with y2, which is 0, minus y1, which is 2, all over x2, which is -5, minus x1. Minus -5 becomes +5. Numerator is fine, that's -2, but the denominator, -5 plus 5, now becomes 0, and this is the tricky part, guys. Anytime you are taking a number divided by 0, that is an undefined slope. Or we would say that the line has no slope. Now, if we go all the way back to the table at the beginning of the notes right here, a line with an undefined slope has to be vertical. Okay, let me make that little note right there. The slope, in fact, let me write this, slope is undefined, therefore the line is vertical. Now, unfortunately, guys, I can't have you go to point slope form the way we did here on this last example because there's no number that you can put in right there for the slope. Remember, 0 is a number. This line right here, this horizontal line, has a slope. The slope is just equal to 0. But in a case like this, there's no number to put in there, so there is no point slope form of a vertical line, and there is no slope intercept form of a vertical line. Once you realize the line is vertical, let's go back to the table now. Once you realize the line is vertical, this is something you need to know, that its equation is just going to be x equals a constant. So at this point, now that it's vertical, we know that it's x equals, and then you just go and say, okay, what are the x values of both of these points? -5, and that's your answer. So horizontal, which we did here in F, and vertical lines, which we did here in G, are actually much less work than everything that we were doing before this, guys. But to be honest with you, students in geometry tend to do worse on these problems right here because they're a little bit unusual. So we want to study some of these horizontal and vertical line problems, and I'll try to give you guys some practice for those on homework, because once you get the hang of it, once you learn to recognize, wait a minute, they've got the same x coordinate, so the answer here is just x equals that number. Once you start to recognize that, these two problems are actually much easier than everything we were doing before. But as I said, it takes a little getting used to. All right, guys, that was a long section. Sorry about that, but that's a wrap on everything in 3.8D. So dive into that homework, see how you guys do. Good luck. Let us know if you have some questions.